Yes, sir.
So now today's lecture is on the classification of states. We already know what is Markov chain, what is the stationary distribution of the Markov chain, what is the initial distributions and steady state stationary distribution, transition probability, transition functions, transition matrix for infinite case or finite case. We saw some examples, different chains like unphased chain, birth and death chain, and Gamble-Ruin problem, some modifications of this, and then we see what is heating time. We all in the last class we see the what is heating time and what is a graph of Markov chain, graph representation. Now, today our class is on the classification of state. So there are different states of a Markov chain. Now we classify these states. Some states are maybe some states are there where if you start if you can't reach there, if you start from there, you always reach there after with probability 1 after some time. And there is a state maybe is not with probability of 1, you may not reach in this state again. So that means if you start from a state, what is the probability that you will ever reach there after a long time or after some time, what is the probability you will reach there again? This type of classification, one is called two type of classification. One is called transients, and one is called recurrent. Now we define some terminology first. So one thing is called accessibility, accessible. What is called accessible or leads to, or sometimes called leads to. So I say I and J are two states. Say two state. I and J are two state. It belongs to state space. Say I and J. So now, if P power n step of transition probability, if it is 0, greater than 0, for some n, for some natural number n, or maybe greater than, maybe 0, maybe I equal to j. If I equal to j, then at the 0 step, it is probability 1. From by 0 step, using after 0 step I go to I, it is just 1. Now, if I not equal to j, then n equal to 0, it will give 0, right? What I am saying, that p0 I comma I, this is 1, but p0 I comma j, which is I j not equal to I, then it is 0, obviously. 0 step you can't go to from I to j. Now so 0 n equal to 0 is a special case. So if for some n this probability is positive, then we say I leads to j, or j is accessible from I. That means when you are in the I state I, it is positive probability that you will reach at j after some time, maybe after 20, 30, something like that, maybe 100, 1000 maybe. Just a minute. So it's clear. So what is accessible? So probabilities from I to j, it is positive probability. It is positive probability. With for some n, it may be 1 core, right? Then we write this. We use this notation I arrow j. We sometimes call j is I leads to j, or j is accessible from I. Now, if there is a both, if I leads to j and j leads to I, if I leads to j and j leads to I, then what happens? Then we, that means I is as well from j and as well as j is as well from I. Then we write, if both are happen, it is if for some, then we write both side implies. Not implies that both side arrow. We write I is this accessible from j and j is accessible from I. I leads to j as well as j leads to I. Now we can easily check that this is the equivalence relation, right? If I leads to j and j leads to I, obviously I leads to I, because with n equal to 0, for n equal to 0 it is a positive probability. Just 1 actually is 1. Now next, if I leads to j, j leads to I, then that obviously implies j both side implies I. The same thing. What is this? I leads to j as well as j leads to I. I mean, what is the right hand side? J leads to I leads to j. Same language. In that first I say I leads to j, then I say j leads to I, which is same as j leads to I, then I say I leads to j. Statement 1 and 2. Right hand side is statement 2 and 1. Now the third one is important. This is called reflexive. Then it is symmetric, and now this transitive property. I leads to both sides leads to j, and j both sides leads to. It's also called communicating. If I leads to j and j leads to I, we say j and I is communicating. So if I and j is communicating and j and k is communicating, then we obviously I and k is communicating. How? We just check its homework. Because if I leads to j and j leads to k, then I leads to k. You can easily check. See, I leads to j means there is some n, say 10. After 10 step from I to j, it goes from I to j, it's a positive probability. Similarly, from j to k, say this is a 20 step, there is a positive probability. Say from I to j, after 10 step, it is positive probability, say half. And then j to k, after 20 step, it is again half. That means is in 30 step from I to k, it is at least 1/4, maybe more than that. Maybe 30 step, it may be more than, maybe with 12 step from I to j and 18 step from j to k. Maybe other way, maybe I from I to L and L to K. So that may at least 1/4, half into half. So positive. So that is, so this, the relation is reflexive, commutative, and transitive. So that's why this is a equivalence relation. Equivalence relation. Now we know if it is equivalence relation, what happens? If there is equivalence relation on the states, now there is a set of all state space. Now there is equivalence relation. That means it creates some partition. We know the equivalence relations create some partition. It creates some partition. Now, so we have different partition. That means in a particular partition, any state from any state to any state we can lead there. Similarly, for any state to any state we can lead there for here. But from I to k, we may go to I to k, but we can't go back from k to I. We may come from go k to here L, but we can't came from L to k. Similarly, from L to say T, we can go, but we can't go from T to L. And remember, if it is from I to k, k to L, T to J, we never from T to I. Then it is a from will again. So if we so happen, there is a positive probability from I to k, different partition, k to L different partition, L to T different partition, T to I different partition. That means from k to I we reach k to I, k to L, L to T, T to I. That means it is I and k will be communicating. So that can't happen. So this is a different partition. If what is called irreducible chain. Irreducible chain means chain means there is only one partition. only one communicating class. That means only one communicating class. That means every state of this state space is communicate with the other state. Every state communicate with the other state. Only one partition. That means every element of the state space is communicating to each other. It is called irreducible chain. One chain is called irreducible. That is, if it is reducible, means there is a more than one partition. That means there is at least there is a two state from is not communicating. That means if I to j we can go lead I lead to j, but then j can't lead to I. So there is a zero probability to j will come to the I with any n. So this is the idea of irreducible and the irreducible thing and this communicating class. Now we define transient and recurrent state. Now আমরা define করছি হবে r x t x y t. What is the definition of this r x y t? It is just probability of x t is equal to I x t equal to y for 1 less than equal to s less than equal to t minus 1. So for some s from 1 to t minus 1, it will reach at x t will be y, given that and also xs is not equal to y, given x0 equal to x. So you start from x. So suffix x, so start always r xy means or something xy means p xy means start from x. So it is start from x. So it is start from x0 equal to x. So the starting point is x. So it reach at y first time. Now it is a reach at y first time. Xt equal to y. Now x1 not equal to y, x2 not equal to y, xt minus 1 not equal to y, xt equal to that. That means from starting from x, it's reach y first time after n step. What is the probability? First time it will reach at y after t step. This probability we denoted by r x y t. So you start from x, reach to y after t step for the first time, not in the before t. Now this is this probably depends on t, right? I will define one more thing. Rho xy is sum over t greater than equal to 1 r xy t. What is the meaning of that? What is the meaning of that? That means start from x is reach to the y first time for t 1, first time for 1, first time for 2. That means at any time, not for the first time, it may be any time, t greater than equal to 1. So if it is reached at y after 10 step, that means it either it is the first time it is reached at y 10 step, or maybe in previous, or maybe 6 step, or maybe 4 step it reached there first time. That means if you take the union of this thing, all these things, first time we reach there, second time we reach there, third time we reach, sorry, not the, sorry, the first time we, after one step we first time reach there, after 2 step we first time reach there, after 3 step we first time reach there, after after n step we first time reach there. If you take the union over all n, what is the meaning of that? That means we ever reach there, we reach. Maybe 1 step, maybe 100 step, we reach there, not first time. Once it is reached the first time, it may be second time, maybe third time. That is a not big issue. If it is reached at first time, then you will again reach it the second time also. Because if we first time after 10 step, if we, from x to y, if we reach there, oh no, it maybe so happen. If you first after 10 step you start from x, and after 10 step you reach at y first time, and from y you never reach at y. Maybe so happen. You reach at y, but once you reach at y, it can't come back to the x. Maybe never go to the x and never go to the y also. With probability 0 from y to y, probability is 0. From y to x also probability is 0. For any n. Then it will be only first time it will visit y. It can't visit 2 times. So that is a different thing. Whether it is a chain from start from x, it is visit y. How many times, that is a different issue. So we assume that there is a visit, at least for one visit or two visit. The question is not a question of one visit or five visit. Question of it is visit one time, first time. How many steps it will, after how many steps it will visit? If it is visit for first time in the first one step, then we will call rxy1. After two step, it is visit first time for y. Then we will say rxy2. And what is rho xy? Rho x is for it is union over all n, all t. So somewhere all sum probability will be sum, because each probability is the case. It is first time, after one step it will reach y at first time. After two step it will reach at y first time. These events are mutually exclusive. Once it is after one step it is reached at first time, it can't reach y first time after two steps. It already reached at y in the first step on the one step. So these are all mutually exclusive. That means sum over all probability. So what is a rho xi means? So it actually means this start from x, it will reach at y. What is the probability of that? It's reach at y. Whether it is first time or second time, or it is one step or five step, doesn't matter. What is the probability of that? It is reach y. Clear? So this is called rho xy, the definition. So what is this by heating time? Heating time, it is start from x, this ty is less than infinity. So it's ty is the heating time. First time it will reach at y. What is the step? The step is finite, because t is greater than or equal to 1. T may be 1, t may be 5, t may be 100, 2 crore, 2 crores, crores and crores, but it is finite. So this is the definition of rho xy. This is a very important concept and very important quantity in a Markov chain. Whether start from x, whether I ever reach at y or not, or if you reach at y, what is the probability we reach at y? It may be 5 step, it may be record 100 step, it may record 2 core step. That doesn't matter. But whether we are reached or not, if you reach, what is the probability? Is it very close to 1 or very close to 0? That's the question. So this why this rho xy, the term is hits y after a finite step starting from x. This probability is very important. Now we say y is called recurrent. We say it is a recurring state if rho yy is equal to 1. What is the meaning of that? Rho yy equal to 1. What is rho yy? Rho yy means it is just start from y and reach again at y, finite step. Remember, t less greater than or equal to 1. So if t equal to 0, then obviously this py ty equal to 0 is 1. It is obviously it is 1. Py start from y, reach at y, and the 0 step, it is 1. So we just take t greater than or equal to 1. Remember that. So now if this probability is 1, that means it's with probability 1. It start from y, it should reach y with probability 1. It may take two core step. It may be some, say, with probability half, it reach at again y after one step. After two step, it will reach again y with probability say 1/4. With probability 1 by 8, 2 cube, it reach at y again y after 3 step. So the sum is then 1 half plus 1/4, 1 by 1 cube, 1 by 2 cube plus the g infinite gp. So this will be 1. Now this is a recurrent state in this case. So recurring state means it start from that state, reach there with probability 1, but the number of steps may be anything, maybe, but it is finite. Now if it is if this rho yy is less than 1, then we call it is transient. Y is transient. It's just, if it is not recurring, then it is transient. That means it is not, you can't sure that it will reach at y again. Its probability is positive, maybe 0. If it is 0, then it is clear. You can easily see whether it is 0 or positive. If it is positive, it is not 1, that means it's not, you can't get guarantee that it will ever reach there again. Start from anywhere, the step will again occur, the state will again occur after some finite time. This probability is positive, but not equal to 1. So you can't give guarantee. But if it is a high, then you can, with high probability, you can say, okay, it will reach y again. But one more question is there. Maybe so happen, there's an interesting thing. Maybe so happen that it is a recurring state. It is a recurring state. That means it ever reach there. But this expected time to reach there is maybe high, say 1 crore. That means it is expected time. It will reach with probability 1. It will reach y again from start from y. But it may require 1 crore many steps, or something like in between, say 99 lakhs to 1 crore 1 lakh steps. So it is a recurring. So that means you can guarantee that it will again visit at y again after, in between, say 1 crore or something, plus minus 1 crore, plus minus delta something. And it may so happen that there is a state which is a transient state, which is not recurring state, but with probability, high probability, it will reach there with after 1 step. So after 1 step, it will reach y with probability 9. It may be so happen. In that case, what happens? In that case, if it is a reach at once after 5, some say very small number of steps, it is high probability. Can it be recurrent state or transient? That is the question. That means if you reach at with high probability or some probability after 1 step, what is the meaning of that? That if you say with probability half, if you reach at 1 after 1 step, again reach at y, start from y, reach at y after 1 step with probability half. That means after 2 steps, you reach at y with probability at least 1/4. That means it should be recurring. So that will be came later in in the theorems. So this is a basic idea. It is a transient or recurring. Recurring is it will come back infinitely many times. It will again come back maybe after a huge number of steps, maybe small number of steps. And transient, we can't give the guarantee. May or may not reach there. Or if it is 0 rho y, that means it never reach at y after any step. So if y is absorbing state, what I mean? It is clear if y is absorbing state, then rho y is equal to 1. It's obvious. That means actually it is, if this is absorbing if you take n equal to 1, then this is the heating time is 1. This probability of start from y, its heating time is 1. This is actually 1. So after one after 1 step, it will reach again because the absorbing state. So absorbing state is recurrent state. So once you are there, it will ever there. Now we'll see some theorems, some results on this different states, classification of in 2 different states. We first define a indicator random variable. We know this indicator function xn is called 1 if xn equal to y. We say it is 0 if xn is not equal to y. If this random variable takes value y, then it is 1. If it not takes value y, it is 0. So it's y. So what is the then probability of this is a very important indicator random variable. What is this? This is actually is the probability of just this random variable takes value y 1, right? This random variable takes value 1. It takes value 1 means it is 1 y xn is 1 means xn equal to y. Now this is, we know this is since it's a Bernoulli random variable, it's only 1 and 0. This is actually expectation. Expectation of the random variable, Bernoulli random variable is just the probability of taking value 1. We know this because it is 1 into this probability plus 0 into that other probability. So expectation of this. So that's a very important thing. This random variables, this indicator random variable. Now we are using this idea. So we are, because this expectation is actually is linear. Sum of 2 random variable, expectation of sum of 2 random variable is the sum of 2 expectation of the sum of 2 random variable is sum of expectation of the 2 different random variable. So expectation of x plus y equal to expectation of x plus expectation of y. So this idea is very important. But in probability we can't do this, something like that. So if we can write a random variable, sum of some Bernoulli random variables, then finding expectations or finding or calculations of variance, it will be easy through this indicator random variable. So that's why it is very important. Now we define this random variable. Now what happened? We define one more term, ny. Ny is a number of denotes number of times n greater than equal to 1 that the chain is in state y. Is state y. So this is denote the number of times. How many times is the chain in y? How many times? How many times is state in y? Now this is actually this ny. You can easily check that this is sum over n equal to 1 to infinity. This, right? What is this? 1 y xn. That means xn equal to y. How many times it is 1? And if it is 10 many times it is 1, that means 10 ones. That is ny equal to 10. And 10 many times is 1 means it is 10 many times the chain xn in y. If xn in y, xn equal to y for 10 times for 10 different n, that means that ends. Say for x1 equal for say x1 equal to y, x10 equal to y, x11 equal to y, x200 equal to y is equal to y. So 10 many natural number xn equal to y. That means that value of 10 ends. Y 1 y xn is 1. The sum is that means 10. Rest are 0. It is 1 and 0. So number of times this chain at y is just ny, the sum of this. Now you can easily check that. Second, it will be homework. That this is ny is greater than equal to 1. What is the meaning of that? That means the chain will be at y more than at least one time, at least 1 or 2 many times. It is never not 0. 1 minus 0 actually. 1 minus the probability of 0. Not the 1 minus 0, it is a complement of the event. This is actually event, this is not a probability. It's even that the chain will be at least one time in the y. And that is actually mean the heating time is finite. Right? The heating time, if the heating time is finite, that means it hits somewhere. If it hit, it may be 1 time, 2 time, 4 time, whatever may be, it's greater than equal to 1. And obviously heating time is infinite means it is 0. 0 means it's never hit, never in the y, so that means heating time is infinite. It's a complement of this. This is a complement. Now clearly, since heating time is infinite means this is rho xy, you can write there, because it's a heating time, it is start from x and heating time is finite. That means it is start from x and this random variable ny takes values positive greater than equal to 1. Now this is the important. That's why we write this ny in terms of summation. This now this probability of this summation, you can just write this in the terms of summation. This sum value is greater than equal to 1. That will help to prove some result. Now there is some easy thing you can easily check. Is a homework that start from x. The heating time is number of times it will reach at y, it is greater than equal to 2. That means it's not 0, not 1. That means we left one thing. So you can easily check that start from x, you go to the y, and then start from y, you go to the y. So 2 times. Now it may be more than that, but at least 2 times. That means you start from x to y, then y to y. Similarly, ny is greater than equal to m means start from x to y first time, 1 time, and then y to y for m minus 1 time. It's more than that. Now what is the probability of start from y and it will be exactly m? That means is actually start from y, it's greater than equal to m minus start from x greater than equal to ny greater than equal to m minus start from x, the ny is greater than equal to m minus m plus 1. If you take the difference, that will be just ny equal to m, and that means you will find this, that this is this m minus 1 to 1 minus rho y by this this. So you can write all this probability in terms of rho xy. So that's why rho xy is very, very important. Similarly, you can find this, the number of times it's reached at 0 is just 1 minus rho xy. It starts from x. One more notation is there. So notation, conditional expectation. So if we start from x, the conditional expectation of y is just expected value of y given xn equal to x0 equal to x. So we start from x. What is the probability? What is the expectation of this y? So it is conditional expectation. We know what it is for any random variable x. Now, what is the conditional expectation? It start from x of this random variable, this indicator random variable. This is very important random variable, indicator random variable. What is this? This we know. This expectation is just the probability of the 1. This probability of this random variable is 1. That is probability of it start from x. Its probability is just yn equal to xn equal to y. And what is this? We know this is the n-step transition function from x to y. It start from x, it's go to the y after n step. That is the n-step transition probability. Now we can easily find this expectation of ny. So it is sum over all these things. That's why we write in the summation notation. So it is just the sum over all this p n x y. What is this? This sum over n equal to 1 to infinity. Just this sum. That is actually intuitively clear. You start from x, you go to the y, after 1 step, after 2 step, after 3 step, that sum, that probability is actually how many times it will reach that expected value. Remember that ny is not a constant number. It is a random variable. Ny may be 5 with probability something, ny may be 9 with probability something. So how many times it will reach? This is a random variable. Remember that. আরে ক্লাস নিচ্ছি তো, রেকর্ড হচ্ছে তো, একটু পরে করতে হচ্ছে না? কি বলছো? আরে ক্লাস নিচ্ছি, কেটে যখন ক্লাস নিচ্ছি। So it start from x to reach at y after n step. That n may be anything. So remember that number of times is visit y. This is a random variable. Remember, we can't say a Markov chain start from y, it visit at y, or start from x, it visit at y 10 many times. You can't like give something. This statement you can't give such a statement that a Markov chain start from a state 0, it will visit 5 for 10 many times. No, you can't say this. This is meaningless. You can say start from 0, it visit at 5 10 many times with probability 0.7. That is the correct. So start from somewhere, you will reach somewhere. How many times? That is a different number. You start from a x, so x you can change that x. You reach y, that you can change y. How many times? It's 10 times, 3 times. You can change that also, and that have a probability. So this probability actually depends on the where you start, while you is visit which step, and how many times. So this probabilities start at y, x, it's visit y for 1 time, 1 many time. That probability, sorry, after 1 step, that probability, after 2 step, that probability, after 3 step, that the sum of this all probabilities is just the expected value of this, how many times it will reach at y from x, start from x. This start from x, how many times it is expected because it's random variable, expected how many times it is, the expectation is reach at y, how many times. If it is a expectation of 10, that means it's 10 many times it will reach. That is nothing but the sum of all this probability. Remember that p n x y, this probability, this in after n step from x to y, these events are not mutually exclusive. Start from x, reach to the y after 1 step, after 2 step, that is not mutually exclusive. That's why the sum of the probability is greater than 1, maybe greater than 1. It's not less than 1, since it are not mutually exclusive. The events are not mutually exclusive. So this is very clear. So it is a very easy thing. It's very easy consequence of all these things, but this is a very important result or theorem. Now, if one theorem is this: if y is a transient state, then start from x, ny equal to less than infinity. This is 1. If it is transient, then that must be 1. So number of times visit is finite, that is 1. That means if it is a transient, what is the meaning of that? It visit 5 many times, 4 many times. This expected value is actually this probability is actually 1. So this how many times? It's maybe finitely many times. That probability is 1. That means it will never visit what y. It is 1 time visit at y, 2 time visit at y. All this finite time number of visits at y. That is probability. That means it can't visit infinitely many times. It can't visit infinitely many times in Markov chain. In y, if it is a transient, but if it is a recurrent, say it is absorbing state, that means is visit y actually not a finite time many times. It's infinite many times. Every time is visit. N equal to 1, n equal to 2, n equal to 3. For all value of n is visit at y. You start from y, say this is observing step. Start from y. For 1 time, first step it is visit y. First time, 2 times it is visit at y. 3 times it is visit at y. So actually is infinitely many times it visit at y. So somewhere all this finite. If I ask that y is the absorbing state, start from y. Can it visit too many times? You say no, it is 0. Probability is 0. For a absorbing state, the start from y, it visit 2 times at y, it is 0. Because after 3 steps, it will visit 3 times. What is the probability that ny will be any finite number? That is all at 0. That is, this sum is actually 0 for recurrent state. And for transient state, it is 1. So there is a question: is it always 1 or 0? For transient state, it is 1, or recurrent state is 0. This sum. So all the finite number of visits, this probability sum is 1. Or for recurrent, that infinite number of visits is just 1. So we'll see in the next theorem. And this expected value is just rho xy by 1 minus rho yy for any x. So how to prove this? The proof is clear. So we know this rho xy is less than 1, strictly less than 1, because it is a transient state. Now what is the probability start from y, and it is infinitely many times it is visit. Now this is nothing but limit m tends to infinity. Start from y, and this ny is greater than m. So this is a limiting sense. Now what is this? This is limit m tends to infinity. This is we will define this is rho xy, rho yy whole to the power m minus 1, but this is less than 1. So some rho yy is less than 1. You are taking this power, and power tends to infinity. That means it is 0. So any number which is between 0 and 1, strictly less than 1, and if you take the n and n tends to infinity, that is 0. Now what is gxy? What is the expected number of visit? That is just m equal to 1 to infinity, m into probability of start from x, visit m many times, that probability with m. This is the definition of expectation. This is nothing but m equal to 1 to infinity, start from x, and this is, we know this, right? This is a very interesting result, that this sum is nothing but this sum. This is in your honors course or even in class 11, you know this. If random variable takes only non-negative integer values or positive integer values, then this sum is actually this is greater than equal to, that we know. This is a very trivial result in class 11 probability. Now this is m equal to 1 to infinity. This is rho xy, rho yy, m minus 1, which is a infinite GP, and since the infinite GP first term is rho xy and the common difference ratio is rho yy, this is infinite GP, so 1 by 1 minus rho yy. So this is again trivial. Next theorem is for this is for transient state, and the next theorem is for recurrent state. So if y is recurrent state, then probability of this start from y and ny equal to infinity. This is 1. This is only 0 or 1. That is interesting. It can't be finite number of visit is half and infinite number of visit is half. No, it's 0 1 law. Either it is infinite number of visit is probability 1, or it is finite number of probability visit is probability 1. It is very interesting. Something called 0 1 law, Kolmogorov 0 1 law, and this gy is obviously it is infinite. And also you can it is from start from y. Now if you start from x, y is a recurrent state. Y is a recurrent state, but you start from x. What happened? Then it start infinitely many times. Now it is just start from x, ty less than infinity, which is rho xy. Now this is not 0 1. Start from x, reach y number of times, that probably is not 0 or 1. But if you start from y, you reach at y, this is all 0 or 1 always. So, and moreover, if rho xy is positive, rho xy is 0, sorry, if rho xy is 0, rho xy is 0, that means you can't reach from x to y, that with 0 probability, then obviously this number of is 0, and if rho xy is positive, then gxy is infinite. So either the expected value number of visit either 0 or infinite for recurrent state. That is a it's common concept. Is a recurrent is either visit, or if it is a visit, is either do not visit. If it is a visit, it should be visit infinite time. So once it reach y, then you come back y with probability 1, again come back with probability 1, again come back with 1. So it is infinitely time is visit. So that probability is 1. You can't say infinite number of visit. You can say the probability of infinite number of visit is 1. Sometimes we call this as infinite number of visit. If it's probability 1, we just omit this phrase that probability is 1. If I say it head occurred, that means it's head occurred with probability 1. So proof is again rho yy is 1. Now recurrent state. Now what do you have probability is start from x and ny equal to infinity. This is again limit n tends to m tends to infinity. Px start from x, the probability ny is greater than equal to m. This is limit m tends to infinity rho xy, and this is rho xy because it's a constant. There is no n. Now, what is the probability start from y? Ny will be infinity. That is rho yy, and it is 1. You got this? Now, what is gyy? Gyy is the expected value of this. Now, this ny is with probability, this infinity with probability 1. So, this is then infinity. Now, if rho xy equal to 0, then what happens? Then start from x, reach at y at after m step, hitting time is m, it is 0 because rho xy is 0. Since it is rho xy 0 is for all m, it can't really hit at y, start from x. This probability is 0 for all n. All m is 0 for all m. Now, therefore, probability of start from x and after n step it will reach at y. What is this? This is sum over m equal to 1 to infinity. It start from x, it reach at y after m step, and then after n minus m step, it start from y, and this it's actually n. It's maybe infinity. So n. So this is yy, and this is 0. This is already 0. So this is 0. And what is gxy? What is the expected number of visit? This again sum over m equal to 1 to n. This sum of all this probabilities. So 0, sum of zeros, infinite many zeros is 0. Now if rho xy is positive, what happens? Then what happens? Then start from x, number of time visit is y, is rho xy, which is positive. Now If rho, two cases, rho xy is positive or rho xy is 0. Y is the recurring state. Clear. Remember that y is the recurring state. X is no. X may or may not be. We don't know. Now, what is gxy? Gxy is again the expected value of this nxy, ny. This is again infinity. So, because it is infinity with positive polarity. So, infinity with positive polarity means the expectation is infinity. Now, there is one more theorem. The theorem is if y be a transient state, if it is transient state, then limit n tends to infinity, that limit is 0. So if it is transient, it's after 1 core many times, after 2 core many times, this will goes to 0 as n tends to infinity. What is the proof? Proof is very easy. Since it is, we know this sum is gxy, but gxy is finite since it is transient state. Now, if the series sum is finite, if series sum is finite, summation of an is finite, that means the nth term goes to 0. That actually means that the limit n tends to infinity, that nth term goes to 0. If series is a finite, if the series converges, that means that nth term, all the terms are positive. Remember, all the term is positive. So since a positive term and this all this positive term and the series is finite, sum is finite, that means this limit should be 0. So this is the all theorems on transience and recurrent state. There is a much more analysis on the in the next class. Transient and recurrent is much this is a very easy treatment, but there is a much more complicated and tough treatment after this class with recurring and transient state. Not so easy, that will be, and then we discuss on the different chain. It's a state. We are now classify the states. Next, we classify the chain, whole chain. Whole chain is this chain is called this, that chain is called that, something like that. Depends on the states of that chain. Different state. One Markov chain have some transient, some recurring, 3 recurring state, 5 transients, something like that. And on the basis of that, we classify all this chain now. Now we first classify the states, different state, different elements of the state space. Next, we classify the whole chain. This chain is the current chain. This chain is that type of chain. That chain is the Barton. That chain is that type of chain. And that Gamble Ruin chain is that type of chain. We are now discuss on this. That is in the Barton death chain. The 0 is that type of state. The 5 is that type of state. We are just considering this type of statement. Now, there is a fundamental difference between a transient and recurrent state. We discuss on the next class what is the basic fundamental difference between there's actually we have 2 different states, transient and 2 different type of state, recurrent state. What is the basic difference between that? We'll recall all these thing result in the next class, and we will discuss what is the basic difference with these 2 states, these 2 states, type of state. Then we go to the different type of class of chain, and then different closed sets and irreducible sets, something like that. And then all this interrelated thing, if it is absorbing, what happened, if it's how many absorbing, and then we discuss on the if it is a reducible or if it is a recurrent state or is a transient state, whether this is stationary distribution can exist or not exist, in which case it is, in which state it exists, and which type of change is not exist, or a steady state exists or not. This type of theorem will be there. And next, we slightly one thing we'll do in syllabus, that is this is not a Markov chain, but is a very close to Markov chain. There's a one stochastic process which is called martingale. Martingale may not be a Markov chain. Markov chain is a martingale, but martingale is a larger class of stochastic process that may not satisfy the Markov chain property, Markov property, but there is a one very close property that satisfies. This is called Markov martingale. We'll discuss on the martingale. That is a much more complicated. Basically, we'll just slightly discuss on that. Then we stop the Markov chain thing, and then we next go to the queuing chain, and then branching chain, and then Poisson process, and then different stationary distribution, and then will some second order process. That will be the whole syllabus. So this is for today's class.